we want to find the standard form as well as all this other information about this hyperbola. I recognize it's a hyperbola because it's got an x squared term that's negative and a y squared term that's positive. So we know this is going to be a hyperbola with a transverse axis parallel to the y-axis, since the y squared term is positive. But we need to get it in standard form. So the first thing I'm going to do is I'm going to look at since the y squared term is positive, I'm going to start there. And I'm going to factor out the coefficient. That's going to leave me with y squared. I'm also going to factor that 14 out of this negative 28. That'll make negative 2y, and then I'm going to make a place to complete the square. Then I'm going to do the x's. The x squared was negative, so I'm going to factor out that negative 6. That'll leave x squared. And I need to factor the negative 6 out of the 36. So that will make that negative 6x, and then a place to complete the square. I'm going to move this negative 24 over to the other side, which will make 124. And then I'm going to put a place to add on the things I needed to add to the other side to complete the square. One of them is in parentheses with a 14 in front, and one is in parentheses with a negative 6 in front. Now let's go ahead and figure out what we need to complete the square. So looking at the y's, we know it's the middle's coefficient, which is negative 2, divided in half, which is negative 1, and then squared. So that's going to be a 1, and we're going to do that to both sides. Now we're going to look at the middle coefficient of the x part, and negative 6 divided in half is negative 3, squared is 9. So 9 is going to go in those blanks. Now these will both factor then as perfect squares. The first one will factor into y minus 1, the quantity squared. And then I have minus 6, and the next one will factor into x minus 3, the quantity squared. And that's going to equal, if we combine all of these things on the other side, it looks like we get 84. Now I'm trying to get this in standard form for a hyperbola, and I've almost got it, but I need to have the right-hand side a 1. So I am going to divide by 84, and I'm going to do that to both of these terms on the left-hand side, and I'm going to do some reducing. So 14 will go into 84 6 times, and 6 will go into 84 14 times. So I now have my standard form. I'm going to write it above the graph here. So it's going to be y minus 1 quantity squared over 6 minus x minus 3 quantity squared over 14 equals 1. So there is my standard form. And now I'm going to figure out where the center is, the vertices, the foci, and I'm going to graph it. So first of all, figuring out where the center is. The center is at HK. It's those numbers with the x and the y, but the x term is second, so be careful when you're looking for the x value. We've got to look over here at this second term. And the opposite sign there is 3, so the x value, the center is 3, and then looking at the y, opposite sign there is a 1. So there is the center of my hyperbola. So it's over 3 and up 1. I'm going to put an x there because I'm going to measure from there to graph the hyperbola. Now I'm ready to look and see what the denominators are of these terms so that I know how far to move from the center in each direction. So I see that I have a 6 underneath that positive y squared, and so that is b squared. So b is going to be the square root of 6. So in the y direction from the center, I need to move up the square root of 6 and down the square root of 6. And square root of 6, if you put it in a calculator, is about 2.4. So I'm going to move up 1, 2, about 2.4. And there's a vertex. I'm going to move down 1, 2.4 about, which is square root of 6. Negative down here, and that's vertex 2. So if I'm listing my vertices, I stayed at the same x value. I took the y value of 1 and I added the square root of 6 to get to the first vertex, and then I kept the same x and the y value of 1 and I subtracted square root of 6 to get to the second vertex. All right, now let's look underneath the x squared stuff is a squared. So a squared is 14, and so that means a is going to be the square root of 14. And if I was trying to graph that, the square root of 14 is about 3.7. So from the center, I'm going to go over 1, 2, 3.7, the positive x direction, and 1, 2, 3.7 in the negative x direction. So that was the square root of 14 each way. That's enough info to see my guide rectangle. I'm now going to make a rectangle that goes through those points and has the center of the hyperbola at the center of that rectangle. I'm now going to draw the diagonals going from the center out to those corners of the rectangle, and those are my asymptotes for my hyperbola. Now I'm ready to draw the hyperbola. The y squared term was first, so we know the transverse axis is vertical, it's parallel to the y-axis, and it goes through the vertex and heads towards the asymptotes. Go through the vertex and head towards the asymptotes. So there's the graph. The only thing I haven't yet found that they asked for is the foci. So let's do that next. The foci are C away from the center along the transverse axis. Remember, the transverse axis runs vertical here, parallel to the y-axis. And the connection is c squared equals a squared plus b squared. And a squared was 14 and b squared was 6. So c squared is 20. That means c is going to be the square root of 20. And if you simplified that, that's 4 times 5. Square root the 4 would come out in front as a 2. And the 5 would still be under. So 2 square roots of 5 is about 4.5. So from the center, I need to move up on the transverse axis 1, 2, 3, 4.5 about, and that is a focus. And then from the center, I'm going to go down 1, 2, 3, 4.5, and that is my other focus. To list these foci, we're leaving the x value the same. We're starting at the center of 1, and we're adding 2 square roots of 5 to get to the first focus, and then same x starting at the y value of 1, and we're subtracting 2 square roots of 5 to get to the second focus.